Hey guys, this is video 15.7. This is going to be a two-part video with this last section kind of to split it up. We're going to talk about the organic reactions you need to be aware of. Some of these are going to be a little bit more familiar to you than others and kind of a little bit more straightforward. Some might be kind of crazy and out there. You got to be familiar with them. Don't try to memorize everything. There's a few big ones that you want to make sure you are aware of. Best thing you can do is to make flashcards for each and look over those each day from here until your Regents exam. All right, because you're probably going to have at least one question dealing with an organic reaction. All right, probably only one. So just make sure you're aware of them and kind of familiar with them. So let's jump right in, guys. The first one is a review. We've done this. We've talked about it already. That's combustion, aka oxidation. Hydrocarbon is burned in the presence of oxygen. So it's always going to produce oxygen and, it's always going to produce water and CO2. Okay, so for example, if we had something like propane, now you guys know how to name that stuff. All right, reacting with oxygen, CO2, and water, H2O. Okay, so something like an alkane. It could be any alkane, alkene, or alkyne. Reacting with oxygen gas. That's the key, guys. These three pieces are the key. All right, I'm going to highlight those in green. These right here. If you see that, this can change. The hydrocarbon can change, but the rest are going to stay the same. Okay, it's going to produce carbon dioxide and water. Okay, I'm not going to spend too much time on it. Make sure you're aware of it, guys. Combustion is that. Okay, the next one is a substitution reaction. So this is where you get one hydrogen atom in a saturated alkane replaced/substituted by another atom or group. A lot of times it's going to be a halogen. Okay, so be on the lookout for halogens that are being replaced. So if something like C3H8 again, so propane, reacting with Cl2, okay, and it would form something like C3H7Cl plus HCl. So notice how it stayed pretty much the same, but now one hydrogen is less, and there's an a halogen in its place. So this is where we have an alkane plus a halogen. Typically, it's going to produce a halocarbon, which you should be able to name from our last video on functional groups. And then an acid is what would form because of that hydrogen. So if we looked at it, it would look something like this. All right, we've got all our H's around our hydrocarbon, and then we have Cl, Cl, and they're going to react. One of the Cl's is going to come in and kick out. So this bond is going to break between the two halogen atoms, and then it's going to come in and kick out a hydrogen. So now we would have something like this. Cl up there, and then hydrogens all around, plus that H bonded to Cl. Okay, so that's a substitution. A substitution, again, it's saturated alkane, so it's going to be an alkane that you have, not an alkene or an alkyne, because reaction number 3 is what we call an addition reaction. Addition reactions, like they say, guys, they're adding, so you're adding different pieces, different atoms to multiple bonds. Okay, so added at the multiple, which is a double or triple bond of an unsaturated hydrocarbon. So it becomes a saturated halocarbon. Two reactants turn into one larger product. That's the key you want to make note of, guys. You're adding two things together to get one larger product. So it's kind of a if you remember back to our reactions unit, a synthesis reaction. So keep that in mind. Kind of one way to distinguish between substitution and addition, which, by the way, these are two to make sure you know. I've seen quite a few Regents questions dealing with these two reactions, so make sure you're aware of it. One larger product. That's one difference between these two. Substitution is going to have two products. Addition is going to have one. So something like an alkene, so this is ethene. All right, plus your halogen, and it's going to be C2H4Cl2 in the end. Again, you're adding in here, so it's becoming a part of the larger molecule. So an alkene, or it could be an alkyne, plus a halogen, yielding a halocarbon. So if you take a look, it should make sense that, hey, we've got space for an addition to happen because, hey, this is not a saturated molecule, meaning there's room, there's a double bond that we could form into single bonds, and that's exactly what's going to happen. The double bond is going to become a single bond between your carbons, and the halogen that you had is going to take the spot of those. It's going to open up, and then you're going to have H's around the rest of your carbons to form all 4 bonds. Okay? So in addition reaction, 1 product is formed. Substitution, you still have 2. It's just 1 subbing in for the other. So again, guys, the name kind of says it all, right? Substitution means 1 is going to come in. Addition means you're adding it to the bigger structure, so only 1 thing would result. All right, so kind of keep those little things in mind, like with the names, as to what to be on the lookout for if you have to identify the type of reaction. All right, number 4, esterification or esterification. Right, so where an ester is created. So again, the name, like I was just saying, is going to kind of tell you what's going to be a product, one thing to look for. So with an esterification reaction, you're putting an alcohol and an acid together by means of what's called a dehydration polymerization. It's a big fancy word, guys. We'll talk about polymerization a little bit later, but dehydration should be your clue. What's one product that's going to be formed? Water. You're removing water from the 2 reactants and then putting them together. So you're removing an OH from one group and then an H from the other piece to put them together to make an ester. So something like this, CH3COOH. So you should be able to think, okay, what type of group is that? What's that functional group just by that name? Where can you look for it? Oh yeah, table R is where I would want to look. Okay, so that is an acid, an organic acid. The Cu on the end, that kind of is our clue that it's that C double bond OH, so it's an acid, plus something like CH3OH. What is that going to be? And this is the hard part between these two because they both end in OH. But because there's a second oxygen, that's how we know that the one on the left here is the organic acid. This is your alcohol group. And I can't spell that. And then it's going to produce an ester, so something like CH3COOCH3. And let's draw what it's going to look like. So again, water is the other byproduct. So if we had something like this, okay, plus our alcohol, which is methanol in this case. You can show all the H's or not. It doesn't matter. If there's just a dash, guys, it's assumed to be where an H is. And then you have your ester. Okay, so something like this. So that double bond. See, notice how the acid, most of it stays there. Okay, that's most of it. But the acid is going to lose the hydrogen, and then our alcohol is going to lose the OH group, and then that's what's going to come over here to our water molecule. Okay, and form that water piece. So you could write it as H2O, guys, or you could write it as HOH to show that. All right, that's esterification. Now remember, guys, esters have that fragrance. Okay, they have a fragrance that they produce. So again, look for the root word here. Esterification means you're making an ester. So if they gave you a whole reaction, you would identify what type of reaction it is. Look and see what your product is. All right, you have an ester there. All right, the next one, and this is a big one to be aware of as well, saponification, guys. This is soap, making soap. All right, ester is always on the left side. Ester reacts with an inorganic base to produce alcohol, typically glycerol, and soap, producing soap and glycerol from a fat and a strong base. So this is one you want to make sure you're aware of. I've seen saponification reactions before. So it's an ester on the left, where esterification, the ester's on the right. So something like this. We have an ester plus a base. How do I know if something's a base? Now, you might think, oh, it ends in OH. But guys, now with functional groups, alcohols tend to end in OH, so it's got to be an inorganic base. Inorganic, meaning it's a metal, all right? A metal bonded with hydroxide. And then it's going to produce an alcohol, typically glycerol, which is this guy right here. and soap. Okay, make sure you know that. So you must use table R to identify these guys. This reaction is very complicated looking, so that's how you can remember the piece that kind of, hey, this is saponification, because it's very, very complicated looking. I'm going to stop this video as part 1 so things don't get messed up with it, and then you're going to pick up in part 2 with the last few reactions.